Content-centric network is a new internet architecture that is expected to replace IP-based internet structures in the near future. Van Jacobson first discussed it in Google Tech Talks in 2006. What is content-centric network and how does it work? Consider you need some particular information from your professor for project work. Instead of having a meeting scheduled up with your professor, you ask your friends living nearby who might have this information. So you send out a message to your friends. One of your friend has this information and you collect it. So in this way you didn't have to wait for your professor, neither you had to increase up his work, nor go to his office. In case your friends don't have the information, they will ask their friends and this will continue until there is a hit and you get the information through the same connection of friends. At the end you and your friends have a copy of the information which you can share in case someone else comes looking for it. CCN works in a similar way. Whenever you type an URL in your browser, instead of connecting over IP address to one of the servers placed all around the globe by big companies, the browser will send several interest packets in the network looking for the necessary data. When a node receives an interest, it checks its local memory, cache, for the matching content. Otherwise, the node forwards the interest packet to the interfaces until the interest packet reaches a content source, CS, that can satisfy the interest. To which the content packets are sent back in the same route to the browser which is recorded in forwarding information base. CCN uses data names instead of host names that are IP addresses and have in-network caching. The devices do not assign IP addresses but instead have a keyword for each data. CCN provides named content to consumers from nearby cache with fewer network hops, thus avoiding redundant requests and overall consuming fewer resources. These nodes are nothing but laptops, phones, and all the devices that have a memory to cache data. CCN works based on how content is named and stored, instead of where it is located as it does in IP-based networks. CCN at each node has pending interest table (PIT), forwarding information base (FIB), and content store (CS). The FIB lists where content is currently stored, while the PIT traces how past requests were forwarded. Nodes also have content packets they've cached in their own content store to satisfy requests. With its growth and shifts in usage, the internet is being heavily loaded every time a user requests the data. The reason why CCN is needed is that it can provide bandwidth and lower latency to many users at once and does it securely. Data becomes independent from location, application, storage, and means of transportation, enabling in-network caching and replication.